I'm going to make a little table. So we have the indeterminate form. And I would probably jot this down if I were you, because this seems like what we're struggling with. And then our strategy. So, so if it's 0 over 0, or infinity over infinity. Okay, those are the first two indeterminate forms we had. They have the same strategy. What did you do for both of those? L'Hopital's. Okay. Then we have the difference. If it's infinity minus infinity, then our strategy is to write as a fraction, and then we get that constant on there to make a single fraction, and then it should be 0 over 0 or infinity over infinity, so then we do L'Hopital's. All right, what was the other indeterminate form we had yesterday?
3 times.
Infinity times 0. Okay, so this one we had to write as a fraction as well. We do that by putting the reciprocal of one of them on the bottom. Then once it's 0 over 0 or infinity over infinity, we can do L'Hopital's. All right, but there are more. So let's talk about indeterminate powers. Page 306. Do we have a volunteer that would like to read? That's what that first little blip is telling you. So when we have something to a power, if it's 0 over 0, 0 to the 0, infinity to the 0, or 1 to the infinity, we cannot just look at it and reason through what the answer is. So those are also indeterminate forms. Our strategy is different. It says each of these three cases can be treated either by taking the natural log or by writing it as an exponential. Okay, so what we're going to have to do, we want to get to the form where we can use L'Hopital's. Okay, but L'Hopital's requires us to have a fraction. So our strategy is going to be a little bit different. Most of the time, what we are going to do is add a natural log. Because with a natural log, properties of logs, exponents come down in front, right? So then it will be 0 times 0 or infinity times, 0 times infinity. So we'll add natural log, write it as a fraction. We can do L'Hopital's. And finally, what's the inverse of a log, or the opposite of a log? The exponential. Since we put the log in the problem to start with, we have to undo it. So we will, how do I want to say this? Change to exponential form at the end. So the process is going to be a little bit longer here. We're going to add a log into the problem because properties of logs allow for us to bring the exponent down. Once we have been able to evaluate the limit, then we have to undo the log we added. So we will add an exponential. Let's look at a problem and kind of explain this. Okay, sine of 0 is 0. So 1 plus 0 is 1. Cotangent of 0, that's a vertical asymptote. That's an infinity. So we have 1 to the infinity. Okay, that is one of the indeterminate forms. So, what we are going to do is add a natural log to this to start. Okay, so I'm taking this inside part. If I put a natural log in front, then with properties of logs, what happens to this cotangent? It can turn into a coefficient. And we know that anytime we're dealing with indeterminate forms, we ultimately want to write them as a fraction. So if I wanted to bring the cotangent to the bottom, what's the reciprocal of cotangent? Tangent. So this is what I'm going to do the limit of. Now, I'm going to make a note to myself right now. I added a log into a problem. What's the opposite of a log? The exponential. So to cancel it, if at the end, I'm going to have to do e to whatever power I get. Okay, so e is the inverse of a log. Have I lost anybody? So let's look at what we have right now. If I put in a 0, we get the natural log of 1, which is 0, over tangent of 0, which is 0. So 0 over 0 means notice I'm writing my limit, Ben.
It's not just me.
So,
It probably is.
It's also me.
what's the derivative of a natural log? 1 over the argument. But we have to do the chain rule here, don't we? Derivative of the inside, so derivative of 1 plus sine 4x would be cosine 4x times derivative of 4x is 4. Over derivative of tangent. Alright, that's somewhat ugly. Let's see if we can evaluate it. So we have a 4. What's the cosine of 0? 1 over 1 plus the sine of 0 is 0 over secant of 0 is 1. So we just get 4. But my final answer is not 4. What is my answer?
E to the 4.
E to the 4. You could have done this in reverse. You could add an e at the beginning, and then at the end do the natural log of your answer. It'll work in either order.
Yeah, it seems easier.
Good. You just don't like the common denominator ones, or?
No, like I meant adding the E
Oh,
at the end.
yes, I like doing the natural log at the beginning.
Yeah, none of this.
Because the reason I like the natural log at the beginning is when you do the derivative of a natural log, the natural log goes away. And then we get something nicer to work with instead of having all the e's. Alright. Let's try some more. Alright, x to the x. So this is currently 0 to the 0. But if I look back at my little summary, 0 to the 0 is one of the things we can't just guess what it is. It's not the same every time. So, we have to treat it as an indeterminate form. We have to try to get it to a form where we can do L'Hopital. So what do I need to do first for this power? We add the natural log. The reason is that the exponent comes down in front. And ultimately, we need a fraction, right? So do you want to try to move an x to the bottom or a natural log to the bottom?
Probably fraction.
Yeah. So the natural log of x over, when I move that x to the bottom, I do its reciprocal. So 1 over x or I could write x to the -1. Either way, you guys like. Okay, so a couple things. First of all, I've added a natural log, so I know my answer will be e to some power. Natural log of 0, that's going to -infinity. 1 over 0 is going to either positive or negative infinity. So this is an indeterminate form. So what do we do? So derivative of the natural log x is 1 over x. Derivative of x to the -1 is negative x to the -2. So this is 1 over x divided by -1 over x squared. How do you divide fractions?
Multiply by reciprocal.
So we get the limit as x approaches 0 of -x. And can we evaluate that? Yeah. You just get 0. But my answer isn't 0. E to the 0, and that is 1. You look like you're about to ask a question.
I don't know what my question is.
Okay. You can wait a second. Okay.
You go.
For once I don't form this.
Alright, so on this one, cosine of 0 is 1. 1 over 0 is going to infinity. So what's 1 to the infinity?
Nothing.
Nothing. We don't know. So what do? The exponent comes down. And this is a nice one to turn into a fraction. What would it look like?
Natural log of cosine over x squared.
And what do I need to make a note to myself of? At the end, it will be e to some power. Alright, so cosine of 0 is 1. Natural log of 1 is 0 over 0. So that tells me we can now do derivative of the natural log is 1 over the argument times derivative of the argument, derivative of cosine, over derivative of x squared is 2x. So we have a limit, x approaches 0. On the top we have negative sine over cosine. Sine over cosine is tangent. Let's just write tangent so we don't have a fraction. Over 2x. What's the tangent of 0?
0.
And 2 times 0 is 0. So it's 0 over 0, which means okay, derivative of negative tangent. Derivative of 2x would be 2. Secant and reciprocal of cosine. Cosine of 0 is 1. So secant would also be 1. So we get negative 1 over 2. So my final answer?
E to the -1/2.
Alright. Why don't you guys try the last one? see how far you get with it. You want me to talk about it? So it starts out 0 to the 0, which we can't do. We add our log, tangent comes down. Okay, we want to write these as a fraction. So we really usually try to avoid moving the natural log. If I want to move the tangent to the bottom, what's the reciprocal of tangent? Okay, so the natural log of 0, that's going to infinity. Cotangent of 0 is undefined, that means it's an asymptote, so it's infinity over infinity, which tells me book house. So derivative of a natural log is 1 over the argument. What's the derivative of cotangent? Let's try to rewrite this so we can see if we can. Cosecant is the derivative, or the reciprocal of sine, right? So could I write this as negative sine squared x over x? Is that okay with everyone? If I flip and multiply? I think that's easier than having a 1 over x and a cosecant, just a little bit cleaner to look at. What's the sine of 0? 0. So it's still 0 over 0, which means okay, sine squared. So exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, over derivative of x is 1. You get negative 2 times 0 times 1, which is 0. So my final answer? E to the 0 power, which is so. I want 4 problems for tomorrow. Then tomorrow we'll be recapping all of it and practicing